We're not economists, we're not sociologists. We're now trees and birds and the sunshine and the wind and the grass and the stray dog and whatever else is seaweed, the waves, that sort of thing. We're in nature. So the biologists study nature. The ecologists study whole systems of nature. So we're thinking in those terms now. So put on your hat. I'm standing as a tree. The wind is blowing me, right? That's all that's going on. We look for data that reports on the health of an ecosystem. So the notion of health of an ecosystem is something that is studied by David Rapport. If you want to look up any of his articles or his co-edited books on ecosystem health, I recommend that you do that because these are very important indicators. The health of an ecosystem has to do with replenishment and growth. As you know, there are cycles in ecosystems. There's death and then there's rebirth. What we learn about ecosystem health is that when an ecosystem collapses, when it changes, when a species is taken away, then some of the functions go away. Some of the quality goes away. It's not that nature dies off altogether. New nature comes in. There are invasive species, but there's a direction to economic collapse. This is what's important, is that the new nature that takes over tends to be smaller species. There tends to be more disease, and there tend to be more invasive species, species that didn't belong to that ecosystem before, or that geography before. The next time that the ecosystem collapses, when something bad happens to the ecosystem, the new species will again be smaller, there'll be more disease, there'll be more invasive species. When it collapses again, then there will be smaller species, more invasive species, more disease. So there's a direction to collapse. And that is why the health of the environment is very important. For the health of the ecosystem is very important. And there's been a lot of work done on what we call ecosystem health indicators, things that indicate whether or not the health of the ecology is good or bad. We also want to think in terms of entropy. So entropy is the degree of chaos. We think in terms of non-renewable resources, that is oil, coal, and gas, because these are things that were created in the environment. They were natural. They are natural. When we burn them up at a rate that's much faster than the rate at which they would be released normally. So any kind of statistics that have to do with our use of non-renewable resources, that is oil, coal, gas, they are of course renewed, but at a rate that's very, very slow compared to the rate at which we use them up. Sorry. And what we want to do is keep track of the rate at which we're using them up. We also want to think in terms of the natural flows of air, replenishment of oxygen, replenishment of CO2, particles in the air. We want to think about the flows of the river. Is the river being diverted? Is the river, is too much water being taken out? Is the river big enough for the fish to thrive in it? Excuse me, I have some cough medicine.
You're a tree with CO2. You're taking it seriously.
Okay, so we want to think about the flows of the air, of the water, and soil nutrition. Right, there are flows of soil nutrition when the soil is not, when there's not, if it's being blown off, we have soil erosion. Then we have to replace the nutrients, and we bring that from outside. But the flows are also those of migrations. The migrations of birds, the migrations of insects, which are natural, and the flows of life and death. It's very normal for in any ecosystem, there's going to be flows of life and death. In some forests, part of the flow is that there should be some low-level fires that get rid of the underbrush. Right? These are natural things. Any data that indicates the state of the ecosystem is counted. So we're interested in biodiversity, we're interested in entropy, we're interested in flows, we're interested in the use of non-renewable resources. All of that counts as the environment, because the environment is both the living environment and the dead environment. So for extracting minerals from the ground, that also counts, because that's part of the environment. Okay, next slide, please. So now we need to think in terms of, and this will be very tricky, think in terms of our qualities again. What counts as the quality of harmony in the environment? What counts as excitement in the environment? And what counts as discipline in the environment? Can anyone suggest an answer? I'll let you think about that.
In terms of harmony, will be the nature just in itself, right? Not transformed by the human.
Good. Okay. So a priori, so we might change it.
Okay.
But a priori, we might think about nature left alone, without humans tampering it, without human interfering, as being in harmony. Because nature without humans manages very well. What about discipline? Discipline is associated with ecosystem collapse, with problems with the ecosystem, with stress on the ecosystem. So what stresses an ecosystem? Pollution, good. Water pollution, soil pollution, air pollution. They all stress the environment. They stress the living environment.
Extensive agriculture.
Intensive, okay, now careful. So we're going to actually hold agriculture in excitement. Why? Because it's human mastery over nature. We're enhancing nature. We're getting more potatoes to grow per acre than would grow naturally per acre. Right? Rather than going around doing hunting gathering, we actually plant things more intensively in order, and we call it, so we'll leave that for excitement. Okay, so all of the agriculture, all of our improvement of nature, when we do selective breeding, when we use pesticides, when we use herbicides, when we use artificial fertilizers, all of that is in excitement. Yes.
Here he asks, Fernando asks, surfaces under protection, natural protected areas, number of endangered species, investments on conservation programs.
Right.
Are those for discipline?
Okay, so if endangered species, very definitely in discipline. That's right, because exactly right. The protected areas are probably in harmony. because we're trying to leave them alone. That's what the protection means. So that's a very nice, and there was a third one, there was endangered species.
Surfaces under protection, natural protected areas, and number of endangered species. Investments on conservation programs.
Good. So investment, again, is money. So that belongs to the economy.
Mm.
Now, because the tree doesn't care how much money you put in. The tree, it doesn't grow any faster because the bank account is really good. The tree doesn't care whether or not you've invested, 10% of your GDP or 0.0001%. It's not going to grow any faster. So we're thinking like a tree or like a worm or like a bird or like the river. So the investment itself belongs to economics, but it's going to, of course, have an effect on what happens to nature. But what we're watching now is nature directly. Is the tree growing better?
Water pollution.
Water pollution belongs to what? Discipline. Very good. Very good. So pollution stresses the environment. It's a difficulty. So it's not too hard to work out what the different categories are. Except that I wanted to put a little note about harmony being when nature is left completely alone. Sometimes we might think this is unrealistic because there's almost no nature that's left completely alone, partly because the air is so polluted. So we might think in terms of for example, the Amazonian forest that is being preserved by the indigenous people. The indigenous people are there, they're having some influence on the environment, but it's very natural. It's the people are living in harmony with the environment. So we might allow that, right, as still being in harmony. Or we might say very traditional farming practices, because they go back many, many generations. So they might belong in harmony as well. But these are good questions, and it's not obvious where to draw the line. So that bears thinking about. Right, let's move to the next slide. Landfill, yes.
The trash of the
Yeah, of course, because we're imposing all our trash on nature. So yes, I mean that is now two things. Let's do two different things. One is the volume of waste that we impose on nature, and then its effect on nature.
The effect is.
That's right. So the environmental effect belongs to discipline. The fact that animals have lost their habitat, the fact that the soil becomes poisonous, the fact that they get tangled up in the fishing nets. Okay, all of that belongs to discipline.
Meaning?
Mining.
Mining, oh, mining.
Mining.
Yeah. So mining, again, that's our imposition on nature. We think we're big and strong, right? We're taking this nice stuff out of the ground. But, so how much gold we take out or how much metal we take out, that's exciting. We're doing something to the dead environment. But it also has pollution problems. Those belong to discipline. The pollution belongs to discipline. But the fact that we're extracting something belongs to excitement. Similarly, when we're dumping stuff, then we're imposing that on nature. The effects of the dumping, the fact that there's pollution in the soil, that belongs to discipline. You see? So let's move to the next slide.
Professor,
Yeah.
so that's really interesting. Domestic extraction of material could be excitement or discipline in this same table?
Yeah, so there are but there's two different aspects to,
Right.
So that's why I wanted to move to the next slide.
Yeah.
Okay, so the name becomes very important. If we're talking about how much gold did we extract from the mine, that belongs to excitement. What is the pollution that results from that? That belongs to discipline. They're two different statistics
That could be in the same table.
in the same table. What is in the table? It has name, how much gold is extracted, how much pollution is produced. That's a separate new statistic. How much pollution is produced by the gold mine. The dimension category is the environment. We're just talking about environment today. All of the data that we're talking about right now is environment. The quality category is different. The one for extracting gold belongs to excitement. The one for the amount of pollution that's created belongs to discipline. So they're in different categories. The same activity becomes analyzed in different ways. So we're doing something, we're the Anthropocene. We are doing something to the earth. We take something out of the earth. But then when I'm sitting there as a tree, maybe I don't care that the gold is, okay, so it's not affecting me directly. But what does affect me is not that somebody took some gold and became rich. I don't care. But what I do care about is the pollution in the soil and the pollution in the water. If I'm a worm and I'm going around and I get this pollution and I die, then I'm worried about the pollution. I'm not worried about the gold being taken out. That's exciting for humans, right? We've discovered something in the earth that's interesting for us. So we pull it out. So that belongs to excitement. But good. So the same looking thing, mining activities are arranged in different categories. Same with waste, right? The waste, this is our imposing things. We just throw stuff out. We throw it into the water, we throw it onto the land, we throw it into the air, because there's lots of smoke that goes into the air, or exhaust fumes that goes into the air. We do that. So that's exciting. The effects for the trees, for the worms, for the birds is not very good, right? Now, maybe a seagull does very well with the waste, right? They get to eat lots of the food. So there are animals that actually manage with the organic waste that we throw out. But that's a small part, right? Overall, the animals suffer from the waste that we throw out. And we change the quality of the water in the aquifers. And that starts to influence the growth of animals and plants as well as humans. And we should take that into account. Not only the effects on humans, but also the effects on the birds, etc. Is everyone okay with that? So the data becomes kind of interesting. How you name it now becomes very important, because the name, it might look the same, but it's going to end up in different categories.
Professor,
Yeah.
there's a question. It's
Yeah.
important to difference between habitat destruction and habitat degradation. Which of those should be more important for the analysis? Ecological depletion? He comes with three terms: habitat destruction, habitat degradation, and ecological depletion. He's interested in know which one is better to use.
All three.
All three.
All three, yeah, use all of them, all of the information. So if you have degradation, I take it that means that there's stress on the ecology, that there's a problem. The ecology is not collapsing yet, but it's stressed, it's under difficulties. It's being pushed, but it has a possibility to recover. This is important. What was the other one? And the other one was,
You said ecological depletion,
hmm?
right? It's habitat destruction,
Right.
habitat degradation, and ecological depletion.
okay, okay, habitat destruction means that's gone. If it's gone, then that belongs to discipline, right? And that's, that, so we'll, in a moment, we're going to keep that question and we'll move to the next slide, because that will feed into the next, no, 2 slides from now. So hold on to the question because it's excellent for the third, for 2 slides away. Okay, so, but we have a notion now of category. We're now going to talk about length. So length is calculated as the radius of the circle for each data point. So you might say, oh, there's, I don't know, 4 species of mosquito that
Sorry, no,
oh,
we didn't have an option.
thank you. So maybe there's, I don't know, 4 species of mosquito that have gone extinct or something. So, because again, we want numbers. We have to deal with numbers because otherwise we can't give a length to the arrows. And we have a notion of normal within harmony, normal within excitement, normal within discipline. What counts as normal depends on what you're comparing it to. So you need what's called a baseline. So we decided in the last session when we were talking about economics to make the baseline the whole state of Jalisco. So we're going to be comparing the biological and ecological data of the Santiago River Basin area to the rest of Jalisco province. And so what's normal is whatever's on average in Jalisco province. Whatever is extreme is whatever is extreme in Jalisco province. So it's Jalisco province that sets what counts as normal, what counts as extreme, what counts as minimal. And then we ask the question, in the Santiago River Basin, are things normal or are they extreme? Is that fairly clear? Okay, now let's move to the more interesting question of the angles. And we had a very nice question about ecosystem or habitat destruction. Okay, so next. Okay, yeah, right. Do you want to? Do you want to?
No.
Okay, okay. Okay. So again, within harmony, within excitement, and within discipline, there's a whole range of angles. A circle has 360 degrees. So within harmony, we have between 0 and 120. In discipline, we have 120 to 240. And in excitement, we have 240 to 360. So the question is going to be, where within all of those degrees, where do things lie? So we had the question from before about habitat destruction. Habitat destruction would be a discipline. So it's going to sit somewhere between 120 and 240. Once you have habitat destruction, animals can't go there. Now, that means that you have a sort of local ecosystem collapse. You put pavement all over the habitat. You build some houses on the habitat. Yeah.
Luis Fernando said, for example, in harmony, the smallest size could be the number of species lost and the biggest the reduce of the basin. The difference between species and ecosystem, where ecosystems are included in a major size.
So an ecosystem is a whole system of different species working together. It's, if you read David Rapport's work, it's something that the indicators for ecosystem health have to do with virility, replenishment, stress and response of the ecosystem, whether it's resilient or not. In terms of biodiversity, we think in terms of type of species, and we think in terms of the actual species, and we think in terms of the functions that the species, the functions that they have in the ecosystem. So one of the functions of an ant is to aerate the soil, bring air into the soil. So if you lose all of the ants, is there something that's still putting air into the soil? And if there isn't, then the soil, the biomass within the soil is going to suffer quite a lot. So we are really interested in the ecosystem, but of course, if individual species decline, or if individual species start to change, start to evolve, then that is going to have an effect on the whole ecosystem.
He said the ecosystem shall be considered in a major size.
Yes, yeah. So quite often ecologists tend to work on very small level in terms of, say, one swamp or something. Since we're interested in the whole river basin area, the statistics about one swamp or 1 hectare or 1 field are not going to be significant for the whole region. We really do have to talk about the ecosystems of the region as such. So and that might be tricky, right? But what you do as a biologist when you study the soil in a particular area is you assume that that is fairly representative of similar areas. So the soil that is being degraded in a particular agricultural practice is going to be similar to the same agricultural practice. If you're growing strawberries, and there's certain types of fertilizer that you need to put in, there's a certain pattern of harvesting, and that pattern isn't going to change from one strawberry field to another. It's going to be fairly similar. So you can use that data to generalize. If you're worried about particular bird species that is collapsing, then you might want to think about the numbers and what is their function. What do they do with the rest of the ecosystem? Is there something else that's coming and replacing that function or not? So that will become very important. But again, there's a direction in ecosystem collapse, and that's very important. When you start to change the ecosystem, you take species away. When the number of species drops below a certain limit threshold, then that species doesn't reproduce anymore. What comes to replace it, nature fills in the gap, but it will fill it in with smaller species, more disease, more invasive species. And it will never recover up to the full thing that we had before. So let me think a bit what we should do.
I have a question.
Yeah.
How do you determine the angle? I mean,
Right. So that's what we want to do now.
okay.
So the angle is going to be fairly rough. All right. It's not going to be exactly 3.986. Right. So don't get too excited about exact angles. Exact angles will come when we do the mathematics on the whole compass.
Okay.
But we can decide sort of, so let's think about harmony. All right, so let's think about the natural environment more or less left alone. If it's left alone and humans are not imposing upon it, not changing it, then it's right in the middle of harmony. Right, so it's right in 60 degrees. So that's a sort of lovely virgin forest in the middle of Canada somewhere that very few people ever visit, etc. as we impose upon nature, as we maybe in harmony with nature, so we have traditional farming practices that might still be in harmony, especially indigenous people's farming practices might still be in harmony. And they're towards excitement because it's humans imposing themselves. The other things that are in harmony but are more destructive are things such as, say you have a park and you have a certain area of the park and some of it gets sold off and more of it gets sold off or gets destroyed. Then that ecosystem is being compromised because it's becoming smaller and that critical mass is being compromised. So they don't know what's happening with the Amazon forest, for example. If you cut away too much of it, that whole ecosystem might die. Yeah.
So the scientific knowledge on biological issues should be placed on discipline with the highest rank?
There's no rank. I don't know what rank means here.
The level.
With respect to what though?
With the rank with respect to what?
The ranking of what?
The ranking in so the scientific knowledge on biological issues should be placed on discipline with the highest rank? On discipline.
No, because we have scientific knowledge about agriculture, and that's not in discipline. And we have scientific knowledge about enhancing species, so selective breeding. We have scientific knowledge about veterinary practices. We have scientific knowledge about fertilizing. So all of that belongs in excitement. It doesn't belong in discipline. But the scientific knowledge about species loss, about ecosystem collapse, all of that belongs in discipline. So that's just that it's scientific knowledge, right? But the knowledge is not, and some of the knowledge might be that a bird species is doing quite well, and that belongs in harmony. So the knowledge doesn't all belong in discipline. I mean, unless that's what you happen to study, right? So I don't know. So if you're looking for certain statistics that only have to do with discipline, so pollution statistics, for example.
He says, can you name an example again for discipline?
From discipline, pollution. Pollution, anything that compromises the ecosystem, or species extinction, the loss of habitat, right? Any of those belong to discipline. So discipline is when you compromise the ecosystem, when it starts to fall apart, when it starts to collapse, when it starts to change in an irreversible way. It can't bounce back again. Anything that does that belongs to discipline. It's human imposition that pushes the ecology in one direction. When we try to enhance the environment, make it better for us. So let's think about agriculture. All of agriculture, selective breeding, the garden plants that we have, the plants we grow indoors, the greenhouses, all of that belongs to excitement. That's humans improving nature. When we cut the hedge, when we clip the ears of the dog, when we breed this dog to that dog because we want this sort of dog, all of that's an excitement. What part of that belongs closer to discipline, and what part of that belongs closer to harmony?
So discipline would be when the agricultural practice tends to be harming the environment, right?
Exactly. Very, very good. So think about agricultural practice, farming practice.
Monoculture.
Right. Any sort of industrial monoculture, lots of fertilizer, pesticides, insecticides, genetically modified crops. All of that is in excitement because we're imposing something. We're making things better at some level, but it's very, very close to discipline because it's compromising, in the long term, it's compromising the environment. Very good. And the agricultural practices that are more organic, more polycultural, more that don't use very much fertilizer, don't use very many pesticides, or use only natural ones, or use fertilizers that come from the same farm, local fertilizer that's organic, that was just produced next door, or fertilizer because we're encouraging pigeons to come and poop all over on the fields, then that's very close to harmony. We're growing food for ourselves, but it's very close to harmony. So that's a very good way of thinking about it. Now let's think about domestic plants, because there's a lot of gardens. So what about garden? When we bring in a new species from somewhere far away, does that belong in excitement towards harmony or towards discipline?
If it's a very invasive one, could be discipline, right?
That's right, very good. If it's an invasive species that escapes, then it's going to be towards discipline, very good. If it's just a little tiny little flower that's probably going to die anyway because it can't manage, maybe that's towards harmony, it's not doing very much. What about breeding? When we breed, let's say cattle, right, to produce more meat, is that going to be?
For the cow, I think it will be discipline.
Yeah.
For us, harmony.
Yeah, so we're talking about the environment. You're
Yeah.
thinking as a cow.
Yeah.
Think as a bovine creature.
Yeah.
Right, so there are different kinds of ways of raising cattle. You can raise them in very artificial environments, which is closer to discipline. You keep them in very small constrained areas. You give them lots of medical stuff.
The chickens.
You make their muscles grow faster, and a lot of things are automated. Then that is the way. I mean, it's still a bovine. It's still a natural creature, but its life is miserable because it's so controlled. That's towards discipline. The bovine creatures, the cattle that are raised on the big ranches that have lots of freedom, they get, somebody sort of herds them once a year and makes them go somewhere. They live a fairly natural life. They spend most of their time just munching grass. They are much closer to harmony. So what kind of agricultural practice is going to move that arrow from one angle to another? Let's talk about, is there a question?
Yes. Cattle is responsible for the loss of natural surface in national level. Is
Good.
discipline?
Yes. So again, then you talk about loss of surface grasslands, right? So the compromise on surface grasslands that we chose to do because we wanted to raise the cattle. But that becomes a separate statistic. The statistic is loss of grassland. And that
Forest, no grassland.
That's right. So sometimes we burn forests to make more grassland. And again, that belongs to discipline because we've burnt the forest, we've cut it down, we've killed that ecosystem.
Y la
So that
tapita que
part of
está ahí,
the
acero,
ecosystem.
también son contactos.
So we've killed that part, and that becomes another statistic. How much forest is being lost to being, and we count all of that into the data table. Good. Let's move to discipline, right? So one of the questions was burning of forest in order to produce grasslands, right? So we burn a forest, that belongs to discipline. Loss of grassland because it's being overexploited, that belongs to discipline. Does it belong to discipline closer to harmony or closer to excitement?
Grasslands?
The loss of grassland.
I think discipline, no?
It's in discipline, but within discipline, closer to excitement or closer to harmony?
I think excitement because we want to obtain economic benefit from that activity.
Good, good, because it's our position. It's us who are doing that deliberately for some reason. We're trying to get what we can out of nature. And we're destroying nature in order to get what we can. Good. What about pollution in the river? Right, this is a big concern. Pollution in the river belongs more towards excitement or belongs more towards harmony? Excitement, good. And now, why is that? Sorry, I'm a philosopher, I can't help it. Why?
We can use the water for all that we want, like drink or,
Yeah, that's social.
well.
The tree doesn't care whether you can drink the water.
We can get that water for regar the trees and irrigate the agriculture.
Yes. Does it harm the agriculture, the pollution? Good. So that's a good question, right? Maybe the water is not so polluted that it harms the agricultural plants. I don't know. That's worth checking. Does the pollution harm the natural plants around in the water? It's probably killing the fish, right? So the fact that the pollution is killing the fish, that gets counted. Whether or not it prevents certain crops from growing, I don't know. Yeah.
It couldn't be considered like goes towards excitement just because it brings a new state
Yes. Yes.
to water.
That's right. So now the ecosystem has to adapt. It has to change. Right. So that brings it more towards excitement. Now, as it stabilizes, as it becomes a new ecosystem with a new set of species, a new balance, once it balances out, then it will move towards harmony, because that will become the new normal, as they say. It will become normalized. It will stabilize. It will be steady in its not as nice state as it was before, but it still stabilizes. Nature wants to stabilize. So as it's degrading, as it's changing, as the balance of different species is fluctuating, it's in excitement. It's in discipline, but towards excitement. When it stabilizes, then the arrow changes its angle and it moves more towards harmony.
And is it possible to see that to see how this dynamically changes?
Yes,
the
yes, yes,
compass?
yes, absolutely. Because you'll update the data. You see, and as you update the data, you'll watch the arrow change for that data point. And that will influence the entire compass. Yeah. So you watch that happen. I mean, you have to be a scientist, you have to watch, and you have to keep track. Is the proportion of, I don't know, green fly to ladybird, is that changing, or has it stabilized? When it's stabilized, it's still in, then it moves back towards harmony. It might even end up in harmony. You see? So it's very interesting because nature wants to recover. It wants to stay there. It wants to stabilize. And then it has cycles. It has cycles that preserve that stability. 400-year cycles, 2,000-year cycles.
Yeah.
That's all part of nature. That's normal. But when we start to impose and we make the cycles faster, so in California, they're having fires every year, major fires every year. They call it the fire season now. So culturally, they've normalized it. And that's very dangerous because it's not natural for the trees. That's not how they grow. Yes.
He comments, nature tendencies to entropy. It depends on timing and scales.
That's right. Very good. The timing and the scale is very important. And the timing for nature is much longer. And the scale is also very important. You don't need, for a species to collapse, you don't wait until you only have one breeding pair. You actually need a critical mass of the animals, a critical number of the animals, and otherwise they will collapse. So, and that scientific knowledge becomes extremely important. And as we're approaching those things, that's when the arrow might change really fast. Because as one species collapses, another one collapses, the whole ecosystem starts to change. Things will rapidly go into discipline. And then they will start to stabilize again and they go back into harmony. But it's a compromised system. There's more disease. So it's as a ecosystem, it's sitting closer to discipline once it has stabilized. Yeah.
Just the last question. Because we are considering harmony as this untouched state or pristine state.
Yeah.
But that might be a point of equilibrium, right? But
that's right. That's
but
right.
nature tends to go to different points of equilibrium as well.
That's right.
And in that case, our compass wouldn't work.
That's right. So that's why that's why I said let's be a little bit careful about leaving nature alone altogether. Is that's in some ways all of your compasses are going to be right in discipline, right? And so it becomes not very useful because then we can't discern anything. So we're going to have to be a little bit more realistic and a little bit more accommodating to the fact that we have kind of taken over nature now. And we've imposed so much on nature. So we're going to think not so much in terms of nature as it would be if there were no humans. You'd have to get rid of 8 billion people. That's a lot of people. So, and I don't particularly suggest doing that. But instead, we're going to think in terms of the stability of the ecosystem. And that stability might be a relationship between man and the ecosystem. That, for example, more traditional farming practices are quite stable. They lasted for thousands and thousands of years. That was, we lived within nature, with nature, and our manipulation of nature was very long-term. It was slow. When we did breeding, it was, the selective breeding was a slow process. It wasn't a fast process. Genetic modification is very fast. That's the difference, is that the time scale has changed. And we don't really know what the effects are going to be. So the issues become quite serious. The very fact that we are including a lot of data about nature in the compass is going to mean that what's happening to nature is going to affect policy decisions in the region. Is there a question? Yeah.
So human intervention accelerates those periods. In that sense, the human intervention has to be considered. And change of land use could be a great data, urbanism, minoring.
Absolutely, absolutely. So urbanism kills the soil, right? When you put cement over the soil, then that soil is no longer alive. What you have are little gardens. And maybe you have some things growing on the roofs and you plant a few trees. The average lifetime of a tree planted in a city is about 7 years. In other words, when you plant the young trees, they just die up.
Mhm.
So urbanization, cementing over, controlling the water so it goes into a gutter and so on, all of that kills that nature. That ecosystem that was there is gone. So that is very much in discipline. When the type of agricultural practice becomes very important. How much we're bringing in fertilizer, how much we're bringing in insecticide, how much we're polluting anyways, how much we're spraying to kill off mosquitoes around the city in order to prevent humans from getting sick. That is affecting the insects. And we should take that into account. That will be in the table, you see. So it's, on the sociological level, it's good for human health. It will be there. But we'll also see the effect that it has on nature. And that will also be in the table. And that's when the compass becomes very powerful, is that things are not good and bad, absolutely. They're good for something. They're good relative to something. They're good within their category, or they're bad within their category. It's good to have for children a playground where they have rubber mats or something on the playground, because then if they fall down, they don't hurt their head. But you've now made a desert. The soil can't grow there. The children don't get to touch grass. They don't get their feet dirty. They don't get exposed to bacteria. So in some ways, short term, okay, they don't bump their head, but they're also, their immune system is being compromised. So there's goods and there's bads. And the aspects, the little worm that lived in that area, it can't live at all with a rubber sheet on top of it. So it dies off. And we take that into account. Did that answer the question?
He also comments, ecological depletion. It's not easy to split nature and society. Talking about effects on large scales and short also.
That's right. That's right. It's not easy at all. And as I said, to some extent, we should be a little bit realistic that we are imposing ourselves on nature. So a very interesting thinker called Kozo Mayumi, who studied very closely Georgescu Rojan's work. My father is very much a student of Georgescu. I'm not officially a student, but he follows his work. Kozo talks about a socially acceptable rate of entropy production. Socially acceptable rate of entropy production. So we have to be sensitive to society as well. We use up our fund of low entropy, that is our gas, our oil, our forests. Maybe we don't replenish the forests at the rate at which we take away the wood. So then we're not renewing it, it's renewable, but be very careful about this is a renewable resource and whether it's actually renewed or not. If it's not actually renewed, who cares? The apple doesn't help any of the trees, right? They don't want to know that in potential they could grow. They need to just grow. So, and we're thinking in terms of birds and stuff. And so the time scale is very different and the values are very different. These are intrinsic values. We depend upon nature in order to live. So the value of nature is not, it lets me show off, or no, it makes me richer. The value of nature as nature is a value in and of itself. It's something that is intrinsic. It sits there. It has value by itself, regardless of humans. And so that's a very different value system. And it's with that value system, when I pretend I'm a tree, and as a biologist, I speak for the trees, or I speak for the worms, or I speak for the bits of grass, then I'm thinking in terms as a piece of grass. Am I being choked? Am I being cemented over? Is the soil aerated enough? Is there too much rainfall? Is there climate change that's preventing me from growing? Are the temperatures too high? Are there droughts? How am I surviving? And that has nothing to do with economic benefit, and it has nothing to do with whether or not society is thriving or not. It's separate. So because the time scale is very different. Are there other questions? So we discussed a little bit about the notion of length, and we discussed the notion of angle. So let's have the last slide. So now we've finished our data analysis, right? Remember that table that we had? Now you have homework. If you don't do the homework, the environment will not be represented in the final compass. So no one's going to speak for the birds or the trees or the worms or the seaweed or anything, right? So it's your duty to make sure that that is represented in the compass. How do you do it? I want you to find, as a group, I want you to find 5 to 10 different data points that have to do with the environment. We talked about a lot of these. They have to be numbers, right? How much mercury is in the water? What is the mercury doing? You want them to be distributed amongst the 3 qualities, the quality of harmony, and because there have to be some statistics that mean that the ecosystems are more or less stable. There's got to be some of them that are stable. Find some that have to do with excitement, our imposition on nature. That's easy. That's all the agricultural stuff, gardening, greenhouses, anything like that. And stuff that has to do with discipline. Again, that's easy. That's all the pollution. That's our killing off of the environment. So statistics 5 to 10 distributed. And this stage, we're sort of guessing. You're going to come back to me with that analysis, and we're going to work on it because when you try to do when you try to fill in that table, you're going to come back to me with questions. You're going to say, I tried, but unless we have specific numbers and specific data points, you're not going to realize what those questions are. So now I want you to go home and to come up as a group, come up with 5 to 10 data points, more or less distributed, and then come to me, and we're going to really do some more in-depth analysis. But right now, you're going to kind of guess on how to do the angle, etc., and how to do the length, and then you'll come to me with questions about how to do that. Does that make sense?
I have some questions.
Yeah.
With the left.
Yeah.
The exercise to compare the Santiago Basin with
Jalisco
Jalisco.
province. That's right.
This will illustrate on the same compass. Is this
Well, then this is how you determine the length of the data point. So what is normal? Whatever is normal and average in Jalisco province. Then in Santiago River Basin, maybe it's more polluted. So then the arrow in discipline becomes longer.
okay. So Jalisco is the reference.
That's right, very good. Jalisco is the reference, it's your baseline. Okay, for pollution, for harmony, and for excitement. And then the length is, so that's how you determine the length. What is the average in Jalisco province? And then is it the same here, or is it different? Maybe there's less biodiversity loss because there are preserved areas. I don't know. Okay, so yes.
So about the homework,
Yeah.
the angle and the length, we're gonna do it us.
Yeah, try to do it, but again, you're going, because if you really try to do it, that's when you're going to start asking questions.
I have a question actually.
Yeah.
Now that we were talking, because we have here data related to the pollution, organic
Sí, porque
pollution in the
esto está
river.
pasando.
Yeah.
So we're gonna take the average of the pollution in fresh water in the whole state. And that's gonna be
Mhm.
our average, which is gonna be our 0.5.
Sí, bueno.
Perfect, yes,
Yeah.
yes, exactly.
And if it goes very close to the average, our data, we will give it a length close to 1, isn't it, or no?
No, then it's still 0.5.
It's 0.5, okay.
It's the average.
But 5 is the, 0.5 is the average.
Okay.
If it
Ah,
was
yeah, it goes-
extremely polluted,
Yes,
then it would be close to 1.
yes.
If it was much less pollution, it would
Yeah.
be close to 0.
Okay. Compared to the state.
Yeah,
Yeah.
that's right. So your state, what are the extremes in the state?
Yeah.
Yeah.
Está embrujada.
It's the
It's
ghost.
haunted.
Yes. We need to exorcise it. Go
Yes.
away, demons. Okay, so maybe we should turn have the people that are joining us remotely, have they asked the questions that you want to ask?
They
No
don't have any,
questions?
no.
Okay, so they should participate for the homework, and maybe we'll just turn the camera off and stop.
Okay. Entonces ya terminamos.
Okay, but turn off the camera.
Ujú. Ya está apagado.